Thanks everyone for coming into the session today. This is the tactical application of additive manufacturing. Today on this breakout session, we have Tom Kelly from Automation Alley. He's our Chief Executive Officer. Pavan Mazumdar, who's our Chief Operating Officer at Automation Alley. And then we also have Matt Townsend, who's the Managing Director of Conway McKenzie. So I will turn it over to Tom to begin the presentation.
Thanks, Eric. And you can go right on to the next slide. So we're talking about building a business around 3D printing. And I just wanted to set the stage before we do a deeper dive into blockchain technology and 3D printing technology. It'll give you a good feel for what we're talking about. So today we live in a very dynamic world, right? We have rapidly changing requirements. The COVID pandemic has had companies all over the world becoming much more agile and much more resilient. In fact, we just had our AmHub sessions yesterday. That's Advanced Manufacturing Hubs for the World Economic Forum. We are one of them as Automation Alley. And when I talk with executives around the world at very large corporations that are part of the World Economic Forum, their number one initiative is to set up a system where they have more resiliency and more agility and less perfectly efficient supply chains. So they're trying to become more agile and more resilient. So we're seeing these changing requirements because of that. We also have a very volatile labor conditions today. So even though, this is an interesting statistic, even though the US has very large unemployment, even at the height of the crisis when unemployment had spiked up to 25%, manufacturers in this area were telling us they still could not fill the positions that they had. Those manufacturers that were open, they couldn't fill the positions. And it's because it's not viewed as a career path for many of our young people going forward. And this is going to continue to be the case. So manufacturing, even today with high unemployment, is still reporting very high labor shortages. So we have to figure out how to solve this problem. And we have supply chain contractions. Supply chains are shifting globally. The potential for decoupling from China is very real and will continue to play out going forward. So this is a threat to stability and the world as we know it, but it also creates a lot of opportunity, especially for regions like ours. And when you couple it with new technologies like 3D printing and the ability to stitch all these 3D printers together using a trusted blockchain network, it really can be game changing. And our ability to go on offense in the supply chain globally, we haven't had this kind of ability in 20 years in Michigan. And we're really going to talk about what's possible. So Eric, you can go to the next slide, please. That would be great. So when we talk about business vitality transformation, it's like a consulting bingo card buzzword. But what we mean by that is, again, to create this secure competitive advantage, we want to create agility and resiliency for the system as we know it here in Michigan. And then we want to be able to take that resiliency and agility and turn it into increased revenue and profits. And how do we do that? Because you're agile, because you can print anything for anyone at any time, it opens up new products and new markets. What happens with 3D printing is if you have a 3D printer, you can make one part in X amount of time. And typically that's defined in hours. That's not very interesting in a scale manufacturing supply chain. But when you stitch all these printers together around our region and we're able to produce hundreds upon hundreds of parts in that same given period of time, you've created a game-changing environment that allows us to go on the offense globally and say, you know what, we can do this as a region. And 3D printing, if part value exceeds material cost, whatever that value is that allows you to say, I can produce the part and I can make a return on my invested capital, if that is true, then 3D printing at scale becomes perfectly efficient, better than any mode of manufacturing. Now, there's a lot of caveats and what ifs and buts and ands in that. But if you extrapolate out where 3D printing is going, 3D printing has the potential to be perfectly capital efficient. And this is what has us so intrigued at Automation Alley. And so when we talk about this more efficient manufacturing, it's really about efficiency and effectiveness coming together. You know, for the last 50 years, we have been on a path that says more efficiency is defined by scale, huge amounts of capital, massive scale in production, and then making that production perfectly efficient with no waste whatsoever. But the waste is in the capital required to get that process to actually work. So if you look at a new system where you say, I don't ever have to have high capital to create scale manufacturing, I can distribute it. Same as Uber distributes rideshare, and I don't need to be a taxi company owning hundreds of millions of dollars worth of vehicle assets. I just take a little margin off of the assets that already exist throughout all of society. The same is going to happen in 3D printing. So Eric, if we go to the last slide, and then I'll turn it over to Pavan. So when we talk about strengthening US manufacturing, this ability to stitch together all these 3D printers really is a two-phase approach. The first phase is we have to demonstrate to Oakland and Macomb counties, our funding sources. They paid us $12 million to build this network of 3D printers that allows us to demonstrate that we can produce PPE at scale in a time of crisis. And that's what we will demonstrate, that we can push a button and have all of you making a demonstration order of PPE, whether it's face shields or nasal swabs or the things that can be 3D printed, we can demonstrate that. It's actually going to be relatively straightforward for us to demonstrate that. But here's where it gets interesting. This is your printer. So one, you can create value in your own organization with the printer. And that's interesting. You can do small scale things. But when we stitch them all together, we want to demonstrate to the world that we can make anything at any time for anyone at scale. That's a really tall order. And anything, anytime for anyone, again, it has a lot of caveats associated with that because you have to be able to have like for like. In other words, I have to make parts that can be interchanged with the state of the art in scale manufacturing today. But there are plenty of opportunities to do that. And we're going to try and demonstrate that and begin to create an independent revenue stream for you. I want you to be in a position as a business owner to look over at your printer and say, I don't know what it's making, but it's working and it's making me money because it's perfectly efficient. I just put it in a box and it gets assembled to somewhere else and off it goes. So with that, I think we've set the stage, Eric, and I'm going to turn it over to Pavan and let him take it from here to talk about blockchain and what it means for this network.
Thank you, Tom. And I think probably the best way to kind of look at the blockchain side of things is to first take a look at, what we do in a conventional perspective. So in the conventional approach, what we have is usually a centrally controlled system where you have one entity that's sort of controlling, the network or a set of assets, et cetera. In a blockchain universe, it's all decentralized. So when you're having multiple participants on the network, they're all participating independently. And so if you look at the phase one that Tom just talked about, where we're talking about building emergency PPE, that sort of uses the conventional approach. And that is sort of to make sure that we can get it through, the requirements that Oakland and Macomb County have put on us, that we can actually produce that emergency PPE. But then when we look at creating an open marketplace for the next few slides, we'll kind of look at how that works. What we wanted to do was sort of break the mold. We wanted to create a marketplace that is actually something that resembles a real marketplace. There's no, individual owner. If you look at all the digital marketplaces that are out there, they're usually centrally controlled. Take every single company that's out there. Take eBay, Etsy, Amazon. These are all marketplaces, but there's an entity behind them. And with blockchain, we wanted to create something that is actually open, distributed, decentralized, and ultimately democratic. So Eric, if you move to the next slide, we'll kind of get into it a little bit more. So when you look at blockchain, The advantages that it has over a centrally controlled system are sort of over these 6 parameters. It's all about security, traceability, transparency, ease of use, cost efficiency, etc. And in the next slide, we'll kind of dig into this a little bit more. So when we talk about reduced transaction time, because there's no third party involved, we call a blockchain network a peer-to-peer system. That means each peer is independent and talking to each other. In terms of expense, one of the things that we will be establishing is a cryptocurrency. And really that's more for value exchange. We don't expect this to be something like a Bitcoin that's going to be openly transacted. That's not our objective. Our objective is how do you keep value transfer effective? So we're conceiving a new cryptocurrency called cubics and chips, and they'll be convertible into standard currency. So like I said, we're not going to be in the cryptocurrency game. That's not the objective, but we want to use all the security and the effectiveness of a cryptocurrency to reduce that transaction cost to make it inexpensive. One of the other things that we have with blockchain is this concept of transparency, traceability, and security. And what we mean by that is in a blockchain, the transactions are actually saved on what's called a distributed ledger. And so when we have a distributed ledger, it becomes immutable. There's a record basically that says, if this person said this and this person said this, it goes into a universal version of truth. You can't really dispute that. Now, you may have disputes over it, and we'll kind of talk about some concepts that we're talking about on how to resolve those. But in general, you can't really, change the version of the truth. Truth is essentially, as things happen, and that makes it substantially more powerful than a centrally controlled system, which could be potentially gamed. And so when we talk about things that are important to manufacturing, traceability, for example, that comes naturally to a blockchain type system. Security, we use highly secure algorithms and secure hashing and encryption tools that make it highly tamper resistant. And there's continuous work going on in the blockchain field to start looking at what's the next level. And so what we're seeing is that the trust level is very high in blockchain systems. Go to the next slide, please, Eric. So why use blockchain? The ultimate goal that we want to put in place is, as Tom mentioned, having a distributed marketplace, but in a marketplace in which every single participant that's on the network can feel like they have a high level of trust, a high level of confidence in the network that says they may not know where the order is coming from, but as long as it is certified that it is coming validly on this platform, they will make sure that they can get paid, that when the product is delivered, that it's all securely managed. For the same thing on the buyer side, if a seller is actually selling something, then it all gets managed correctly, effectively. The distribution gets taken care of. All of that is what we're building in this blockchain network. And so phase one, when we talk about using the printer for the distributed PPE network, it's going to be much more of a centrally controlled system. But then as we build phase two to build this distributed marketplace, it's going to be about how do you create your own store on the system so that you can transact and market your products. Along with this, over time, we'll have the ability to do digital assets. So let's say you're a designer, and let's say you have this interesting, component that you have designed using 3D software, and you don't necessarily want to additively print it, but you want to make it available on the marketplace. You can actually sell access to your software, to your designs, but you don't just give it away. You might give it for certain number of impressions, and the design stays yours because it's encrypted. So you don't give up your IP. What you're giving up is access to your IP. So there's all kinds of possibilities on how do you build a business, not just in the printing of 3D printed products, but supporting the 3D printing product universe, production universe. And in the next few slides, we'll see why 3D printing, why is that so interesting? Industry 4.0, as we've seen, had a number of pillars, but why did we focus on 3D printing? So I'm going to turn it over to Matt to talk more about jumping right into 3D printing and understanding the promise of 3D printing.
Sure, thank you, Pavan. So if you look at the title of the slide, it's called Additive Manufacturing Growth. But before we embark on the notion of why, I just want to touch on understanding of the what and what is additive manufacturing. So simply, it's the opposite of subtractive, or the traditional way we've manufactured just about everything. So how many of us in the room have or on the Zoom call have started on a Bridgeport in their careers and squaring up blocks and making details? So normally when we made everything, you remove or subtract material, so you end up with a design intent shape. So with 3D printing, it's the opposite. We're going to build the shape one brick at a time and add material together until you've designed something the way it was intended or the way it was actually drawn as a solid model. So this is what we call a transformational disruptive practice. So I commonly say, when you design for additive, forget basically everything you've learned or ever been taught. So I'm a 30-year manufacturing vet. And the first thing that I always think of in terms of tolerances or manufacturability, especially when it comes to surfaces and hole positions, as we embark on the new technology or the new way to design, there are many tricks of the trade that we just have never learned before. So the industry trend data shows that 3D printing will expand as quickly as technology will take it. We all remember what our cell phones looked like 20 years ago. Nothing like what they look like today. That is all software, and the changing world that evolved around it, while 3D printing is no different. So the hardware is not the difference. This game is all about software. The leader in the 3D printing world is the company with the most progressive software that drives it. Better, faster, is all driven by software. So you can easily see the experts are projecting the printing industry will roughly move from about 20 billion to 150 billion in sales of products and services over the next 20 years. Next slide, Eric, please. So now that we know where the market's going, what markets are we expected to take us there? And so in our neck of the woods, we care about aerospace and defense and automotive. So if we look at the aerospace slide here in front of us, low volumes and the agile build anywhere idea suits this industry, obviously. So if we look at the total available market for additive, it's currently at about 100 million. The trend in purchasing and design to the evolving market turns it into a $5 billion workplace, or approximately 10% of the total expected 3D printing volume at that time in 2025. Next slide, Eric. So now we're talking about factory tooling, and I think this is the area that most of us are interested in, especially by our proximity to the automotive industry. It is very, very prevalent to all of our livelihoods. So the vast majority of the products made today with 3D printing will only expand further and create a massive amount of sales growth in this segment. So engineers are using the power of design for additive to fuel a new world in the area of tooling. As we are a backbone in the tooling industry, we need to get on board and get with the program of 3D printing. So Project DIAMOnD is feeding the need and using this platform so that we can make a huge dent with the adoption of this movement. Next slide, Eric. So the differences between subtractive and additive are plainly seen with these 6 examples that are on the screen here. So the main takeaways is we use new technology to solve problems. And the 6 key problems that I posted on this slide are structural performance and optimization based off design, geometry that you can design using additive that you could never design using traditional methods, converting assemblies that have multiple bits and pieces that may get assembled together, you can print as one. Lightweighting for end of arm tooling, which is a staggering amount. And if you happen to walk through the new truck plant just up the road at Mound Road, it was all done printed by additive in terms of hanging doors. Product personalization, so the ability to add a certain characteristic to a certain product just as a one-off, and the time to market is obviously staggeringly quick with no tooling. Next slide, please, Eric. So last but not least, on the 3D printing venture, we are using the knowledge gained by the software to make itself better. And so what that means is we use crowd surfing, or we use crowd adaptation of process to make the ability to generate the product better. So every time we make a print inside the network, it looks at where its position is, what its output was. We'll be in the future doing a scan of the product sitting on the bed after it's printed and communicating the positions back up to the software itself. So basically, we're using an iterative part in order to try to continually strive to make a better and better part each time it's printed. Next slide. And I think that's it for my portion. I'm going to turn it over to back to Eric and get some questions going here, because I think we've got about 30 minutes left in the discussion.
Yeah, thanks, Matt. As I'm pulling up the questions here, one of them came up. This one's for you, Tom. Can you talk about what maybe like OEMs or tier ones would want to have in terms of parts put on the network, like what parts they would want serviced?
Yeah, that's a really, really great point. So, you know, I won't name names, but we're in discussions with, if you think about the problem the OEs and the tier ones have on vehicle parts that have run out. In other words, you know, you're obligated to support a vehicle for 10 years or whatever. But the vehicle's in production for 4 years. And so you get all the production value of the quantity of parts, but then you have to support those parts for another 6 years. And so, and possibly much, much longer than that. And what we're finding is OEs and tier ones are getting their butts handed to them by the Chinese in terms of counterfeit parts that come into the aftermarket for older vehicles. And there isn't a good way to counteract that, because nobody wants to build inventory on what if scenarios, especially inventory on a vehicle that's 8 years old. And you say, I'm going to pull the die off the shelf. I'm going to do some production run, then I'm going to guess it. Then I got to push the production out to distribution centers, and it sits there. And I don't know how many times you've ever gotten a part sometimes where it's caked in dust because it's sitting there for years waiting to get purchased, may never get purchased. And you have all that has to get built into the financial model to make that work. 3D printing solves that problem. Now there's issues with sort of the PPAP process and how you allow that to happen. But we're in talks with different organizations and different OEs and tier ones to say, how do we start to begin to change the process so that if you need a part for a vehicle and that vehicle is 8 or 10 years old, you can just make it. Heck, you can have a shop local to that customer make it right then. I need that part. Yeah, that part's going to be ready in 2 hours as soon as the printer's done printing it. It's ready to go. So think about, it kind of blows my mind when you think what the possibilities are just on the OE side for these aftermarket parts, where you have a long tail. Vehicles are lasting longer and longer. Heck, the average age of a vehicle today is 12 years. I think it's the highest it's ever been. And you have to support all those parts. And it's not really that profitable today. So maybe Matt and Pavan would like to jump in, but that's just one example. And there are many examples where it's efficient to do very large production runs early, and then that tail gets you, because you have to maintain profitability on that obligation for years and years and years. And what a great way to change the whole story. And in fact, tier ones may say, I'm not going to make the part. I can't really do it anymore. I'm going to license the IP to a little guy, one of us that we're talking about that has a 3D printer, and I'm going to just push the part to you in a secure way. You can't ever get at that. Your printer sees it, but it's all encrypted, and everybody makes bank in that, right? The tier one makes their money. The OE's happy because the tier one is fulfilling their obligations for level of service. And the small guy says, this is wonderful because I was never in this business before, and all of a sudden I'm making money producing parts that are needed for a long time.
Yeah, and on that same note, Tom, the AIAG we are not alone in the adaptation of software. So as autonomous vehicles come along, AIAG have already started to change their PPAP regiment to PPAPing a software. So it'd be the
Right.
same idea with service parts on a 3D printer. Is the software that the part is being printed on now becomes the engine, and the hardware that physically comes out of it is just a byproduct.
Right. And you know, it's no secret. And so Automation Alley and AIG are talking together. Scott and I are talking about how to make this a reality, because if we bring together this capability, 300 printers, and by the way, 300 is just the start. Why couldn't we have 2 printers per site? All of a sudden you have the capability to do 600 parts at a time, 900 parts, 1200 parts, right? You see, it's ridiculous to talk about the limits of scale because it's so reasonable to say, look, if I'm profitable at 1 printer and you can show me I can be profitable with 2 printers or 8 printers, I'm going to do it, because it's now in my interest to build this parallel manufacturing path. As I transition from my subtractive world to my additive world, we can do both without causing you heartburn in terms of the capital required to sort of go along this path while you're doing the subtractive work you continue to do.
And you brought up a great point, Tom, talking about scale. So I think everybody on the call today needs to understand that the biggest problem with 3D printing in the past was I put 1 or 2 of them in my shop. I need to print 400 widgets for my assembly line. It's a 2-hour print. That's 800 hours. You know, off the 2 printers is 400 hours plus load and unload time. I don't have 400 hours to wait. Now you've got 350 printers. That 2-hour print, my 400 widgets are now done in 2 hours. So the ability to scale based off of this network is staggering. And you want to talk about disruptive to the universe. Every guy in town who does assembly line equipment should be looking at this saying, hey, I can now print every block, every gadget, every widget, anything that we need to put on side this line that we normally traditionally just square it out of a block. They need to change their tune and change their thought.
We had a question come in along the same vein. So how would these printed parts compare, or, you know, how profitable would they be compared to like cheap imports that come from outside of the United States, in this example? So how does it compare in terms of cost?
Yeah, so I'll take the first whack at that, and then you guys can jump in too. So here's the issue. 3D printing is in its infancy, but there is a bell curve of parts, right? And there's going to be a vast amount of parts that are not cost competitive yet. But when we look at the parts that are competitive, it might be 10% of the global population of aftermarket parts. But that's a huge number when you think we're sitting here in Southeast Michigan and none of you have participated in this aftermarket business. And so the total addressable market may be small to start, but for our little community, it's a huge opportunity. You know, our estimation is we're talking tens of billions of dollars of potential parts that we can identify that exist in the total addressable market, maybe more than that. But the idea is you just have to be very deliberate, and we have to say, we have to find parts that are profitable to make for 3D printing, and then we have to find willing participants. So Automation Alley is working very hard as your sales people. And, you know, Pavan and I are your sales force with Matt to go out and say, how do we get large OEs and tier ones to say, you know what, let's try this. You know, we talk about silly things like, why in the world are we making you know, little grommets over in China and having them all distributed and all that, when you can just say, let's make the little grommet that holds the carpet down. Customers would be delighted where you say, look, there it is. You got it. You can actually find it. You know, one of the problems with OEs and with like other industries like Whirlpool and all these others, you can't get the parts. You have to scrap the dishwasher. So we might even be in conflict sometimes with OEs because they're like, I don't want them to maintain that dishwasher for another 3 years. I want to scrap it. and I want to get a new dishwasher. So there's complexity here, but we can't hold our eyes and say we don't understand how fast the technology is going, or we want to keep it at bay. We have to embrace it. We must move forward together and say, we're going to let the technology take us where it goes. And we have to build business models that give us competitive advantage, understanding where we're going.
I'd like to add to that. So I think Tom gave us a perfect setup. And the way we look at this is, everything about this is skating to where the puck is going, right? So even if you look at that 3D printing addressable market, it's small today, but it is growing exponentially. And that is unusual in the subtractive world for something to grow exponentially, but it's growing exponentially because of the capabilities of software. The other thing is, the nice thing about 3D printing is the cost of a 3D printed product is actually a relatively simple equation of how much time does it take and how much material does it take. The product complexity has very little impact on the cost of the final product. Yes, there's cost upfront in the design, but the design is information, and that is infinitely scalable. So that's what makes 3D printing very interesting. So you can have really complex products today that cost a lot more to make using traditional methods because of the complexity of the product. But the complexity of a 3D printing product, all it's going to ask is how much material did it use and how much time did it take to print. And so we are going to be looking for what is the low-hanging fruit. What are the products? What are the components that are expensive and that are hard to source? And can they be sourced through this printing network? And then is there a willing customer to go buy these? And then how do we push them through the network so that everybody on the network benefits? That's really it makes it a little bit simpler. Yes, there's a lot of upfront work sometimes to be done because sometimes these products may not have the 3D printed design. They may not have the STL files, etc. So there's work that needs to be done to make it ready for additive. But that's the thing. When Tom says we are the salespeople, we're kind of like the sales engineers. We're saying, what are the opportunities that we should be focusing on? So if it's not cost competitive in 3D printing, let's not do it. Let's not waste our precious material and assets and your time. The other thing is, as we get ready for this high volume marketplace, one of the things that you have to do as participants is build the workflows internal in your organizations to start being 3D printing companies. You have to start understanding how 3D printing works as a workflow. How do you feel more comfortable with the software that is there? How do you feel more comfortable with design and manufacturing for additive? All that is up to you. So you have a pretty heavy lift as well. If you're in the subtractive world, making that transition to the additive world is a different mindset. It's what Matt said earlier. Everything you knew about manufacturing is now open to question. So you need some time, and that's the opportunity that I think we are trying to give companies to say, start playing with this so you start building the muscle to be additively capable businesses. And Matt, I don't know, you've actually done this, so I'd love you to kind of talk about your experience in how you kind of made that transition from traditional to additive, and what that meant internally to your processes, your workflows, your organization, etc.
Sure, and we did this around the world in multiple sites and used our tech centers to feed basically the workforce, let's call it. And in that area, there's basically a crossroads that says, okay, the complexity of the part versus the actual material of the part. In some cases, there was no material available to make that part, so therefore it negated the ability to use 3D printing. And then there were many cases where it was. And so that portion of life, like in my slides earlier, is tooling. And so the tooling portion now becomes very, very acceptable in the 3D world in terms of strength of the product. It is extremely light, and it is easy to make iterations. So we've all designed something, built something, went to go put it together and went, I missed that bolt, or I missed that something, where now you have to remake it again. So iterative design in 3D printing makes it extremely valuable that I can make something, design it, print it, test it overnight potentially, or even a couple of hours, and then I can make modifications to it to make my product that much better. Now, when we talk about 3D printing to something that is extremely uncomplex, like a flat washer or something very negligible, it now does not make sense. But where it does make sense is the creation of the tooling. So if that tooling doesn't exist to make that widget or that flat plate or that something that only costs a penny, and I need 50 of them, I don't need to build a $15,000 tool to make 5 or 15 or 20. So that is where 3D printing power really comes into play. In the very low volume niche, I have to make something and I need a tool to build it. That is where we can be very impactful in the market.
Yeah, but man, I would say where the world is going, where the puck is going, is that flat washer is not profitable today because culturally we haven't arrived to say, why would I ever why would I ever make 1 million washers in China and then distribute them through a colander all through the US to all these little places where have these little washers? Why wouldn't I just own the IP and everybody is going to have 3D printers? And you're going to say, oh, I need a washer. Well, boom, I don't even look up. There's all right, there's the washer, hit the button and it's printing. And 20 minutes later, I have it. And I don't have to call Granger and have them run over a stupid little washer to keep my plant going, right? This is the kind of thing that culturally we're not there yet, but that's where we're going. And you got to say, look, within 20 years, this is what manufacturing is going to look like. It's going to be instantaneous and people are going to own and distribute IP, not physical products, because the physical product will be made locally, right at your shop. And you will use, and the last thing I'll say is you guys need, this is your community. We're birthing it. Automation Alley is, and we as a nonprofit, we will help govern it to make sure that you know everybody can communicate, but it's your system. So one of the things that we want you to change your mindset around is you have a 3D printer, but you now have 300 3D printers. You have access to this whole network. The idea is to feed off each other and build a community where you're using each other's assets to create wealth for everybody in the ecosystem. That is game changing. That's globally game changing. And, you know, we created the second industrial revolution. We owned the third, and by damn, we're going to own the fourth. And this is the way you do it. You build this cultural change where everybody uses everybody's assets to create wealth.
Pavan, this next question's for you. Let's say if one of the customers is on the Department of Defense, is every company expected to be NIST compliant and CMCC compliant? So how do companies navigate those extra layers of security that they may have to go through with the Department of Defense on the network?
Yeah, so that's pretty involved question. So the general answer I will give is no. I mean, if you're and I'm assuming this is the question related to the marketplace, right? To the blockchain marketplace.
Yes.
Right. So our expectation is going to be that, and again, this is sort of a vision, and you're going to have to kind of help us build this as we go along. But our vision is your individual participation in the marketplace is sort of your approach. In other words, some companies may choose to do business with the DoD, and they have to go through that process. They have to go register in SAM, they have to get their cage code, they have to get the NIST compliance, et cetera, et cetera. Other companies may not wish to do that. And so from our perspective, anything that we provide as a portal into the network, into the blockchain system, we want to make it NIST compliant. In other words, we want to be able to say to someone like a DoD, you can be a participant, you can be a customer on this network, and you can confidentially and with a high level of integrity send your orders over this system. But that doesn't mean that other parts of this company may be compliant. And all it means is that if you're not NIST compliant, if you're not doing DoD work, you just wouldn't get that badge or that certification for your node on that network. That's sort of how we see this happen, right? So you can have 1,000, 1 million companies, potentially more on this network, but only a small subset, let's say 50,000 of them, I don't know, I'm making up numbers here, are certified to do business with the DoD. And those 50,000 will have a mechanism to participate on this network. And because these transactions are all encrypted and flowing through the system, no one can actually see what anybody else is doing. It all becomes a secure system. But these 50,000 companies can also do business with non-DoD members. And so what we're really doing is we're building an open marketplace that resembles the marketplace as we see the physical marketplace that we see in the world. You can buy something securely, but you can also then just go to Target and buy something, and the levels of security are different. So that's how we see this happening, and we're kind of looking for feedback and information from all our participants as we build this. It is, as Tom mentioned, it is going to be built by the feedback and the input of the community. Our role in this is to play the governance entity. Our role is to create the system of governance that makes sure that everybody is treated fairly, that the level of security and the confidence you have in the network is very high. Beyond that, we will be taking advice, we will be taking input from everybody to say, how do you transact something like this? How do you kind of put this in place? And that's why it'll be a while before this thing kind of ramps up. But we hope it'll be an interesting ride, and we definitely see that that's where the puck is going. Before you continue, Eric, I did see a question on the chat. Someone asked for the slides, and yes, we'll make the presentation available for download and figure out a way to kind of get it to you.
In fact, on Pathable, we can post it right to the files side.
Yeah, so let's do that.
Right on this Pathable over here.
Yeah.
Okay, perfect. Matt, this next question's for you. Can you talk about why we chose the Mark II, the X7, and the Metal X printers for this project specifically?
Yeah, so the X7 and the Mark II are basically the same. They are both continuous fiber printers. And what that means is that the base layer is onyx, and then we can interweave a layer of carbon fiber, fiberglass, a myriad of different products that will make the part stronger. And it now has the ability to move closer to aluminum in terms of strength. So I believe in the chat they were asking why not an X3, and an X3 is a little bit different. It's a fused filament fabrication printer that is strictly only for onyx. So in hindsight, the ability for us to make an industrial part is the printers that we chose. If there is somebody that is in our audience that has a real necessity to only use that fused filament printer, I would like to hear them out. But in the vast majority of things we will be printing on these printers, it will be an industrial strength, and therefore that's why the Mark II and X7s were picked.
Yeah, this one might be yours, Tom, to answer, but I'll kind of open up to all three of you. So are companies able to grow the network of printers by purchasing additional ones themselves?
Heck yeah,
Yes,
we'd love it.
absolutely.
Well,
Yeah.
with that said, we're building a community at the same time we're trying to build an economy. And so that second printer, you would purchase that because you're like, look, Tom, I'm making profit with the two printers I have myself. And I'm not relying on Automation Alley and the economy we're building with all our collaborators in the network. That's going to take time. That's going to be an exponential curve where it seems like it's zero forever, and then it just kind of inflects, and then it takes off. It's our job to go out and build the business with defense, with OEs, with tier ones, and say, look, we have all this capacity with the Walmarts and the Whirlpools of the world. Industries we may never have been capable of having competitive advantage in, all of a sudden, because we have printer scale, anybody that's in the business of needing 3D printing scale, Southeast Michigan has it. So we have to think about how do we do that. But for you, I wouldn't say, hey, park another printer on the network because we'll be able to have 301 printers going all the time. It's like we're going to struggle for a while to get those 300 in the economy. But our hope is while we're waiting, it didn't cost anything. We granted this printer to you. You're spending time learning how to use it, learning how it impacts your business, perhaps sharing with us these great success stories of how you were able to make a part for your, an MRO part for your machine right on site, and it worked beautifully. There's going to be all kinds of these great examples. But so yes, we would love to see you have a second printer or more. That means you're really embracing the culture shift.
I would personally see that as a sign of success if companies said, hey, I want to buy a second and a third on my own, because that means that the business opportunity, you are actually seeing benefit in it and you're investing your dollars in it. I would see that as a very, very positive sign.
This one's for you, Matt. Will the product costing models be explained in the training that each participant's going to be provided through this grant?
I'm going to answer that with yes and no. So currently today, when you generate a print file, it will give you an expectation of time and material. So the factor of time times X in order to give us what that overall part cost is not calculated yet. I don't know, Pavan, if you wanted to jump in to say anything, but what you will get is you will get a material cost that is very accurate, and you will get a print time, which is also very accurate. It's just going to be what that factor of print time times overhead number will be for a true cost.
Yeah, so what I'll say is one of the things that we're doing in parallel, right? And Tom mentioned we're building an economy, and that's exactly what we're building. So part of building an economy that is fair is to make sure that everybody that participates in that economy has excellent insight into the transparency of their costs. So in parallel to what Matt just said, we're exploring building cost models that we absolutely want to empower our companies on understanding, so that they can essentially say, hey, this thing costs me X in material, X in time. I need to put some capital cost on that printer. And by the way, even though this printer is going to be granted to you, we want you to start thinking in terms of as if you paid for it, right? So what would that total combined cost be? And then a per part cost. What's, for an additive shop, what are some ranges or markup or gross profit, however you like to address it, that you should be putting in, so that you have a final unit cost. And that is, again, going to be a function of volume, depends upon how many you make, right? So we want to kind of create these models that we want to share, so that everybody becomes not just adept at the nitty gritty of making it, but also building the business around 3D printing. How do you create a financial model that gives you that return on capital and generates the cash flow necessary? So we have to kind of put this in. I just see a comment from Cliff. I'm a cost engineer, develop cost models. Can definitely, awesome, Cliff. We would love to hear from you. So this is exactly that community model. So
Cliff had another question, Pavan, too, which said, will other companies be able to buy into the network, or do they need to be part of the initial grant? Well, of course. Yes. Absolutely. In fact, you don't even need to have a Markforged printer. Anybody who has a 3D printer, we want to know who you are. If you're interested in coming on the network, we'll figure it out. We'll figure out how to get you part of this blockchain community. D. Smith had a question: how much will the second and third year warranties as recorded by the contract cost? I don't know if we have that fully fleshed out yet. That's why we made the contract super simple. It says, look, at any time, if you think you're getting a raw deal, just drop the printer back off, right? It's easy peasy. We're not trying to create some sort of hook that locks you into some economy. You're like, I didn't bargain for this, because we don't know. We're building this as we go. We're changing the engines out as we fly, so to speak. And Pavan, Matt, and I and Eric are running by the seat of our pants, trying to put this all together. And we need your help to do that. So when we say we don't know, we don't know. I mean, the warranty is easy to figure out. Matt can get you that information, and we'll figure out how to get that posted somewhere that says this is what it'll be. But we're trying to, by the way, that was a requirement of Oakland and Macomb County. If you want to run it without a warranty, that would be fine by us. But Oakland and Macomb County are saying, hey, it's our federal dollars we're using. We want them to make sure this can work for the 3 years that they're obligated to produce PPE in an emergency. So I understand their point, but it raises cost. I understand that.
I have another question. This might be for Pavan or Matt. Material costs and time to print are impacted by part orientation, finish, resolution, so the layer thickness, and the printer used. What is the plan with the blockchain process to ensure consistency between the suppliers?
Good question.
Good
So
question.
I will answer the question with I don't know fully, but one of the things that we're doing is we're actually think of the blockchain platform as sort of three layers. So there's a foundational layer, which is the blockchain piece of it, which we've really focused a lot of our energy on, and that's the distributed ledger technology. That's the exchange of value. That's the smart contracts. If you know a little bit about blockchain, and a lot of this stuff is there's a ton of information. If you're interested in it, you can go down many rabbit holes in blockchain. But all that stuff, we are kind of putting that part of it, developing the governance around it. On top of that, what you need is a communications layer. And the communications layer is taking that underlying information from the blockchain foundation and being able to communicate with third-party applications. On top of that, what we're envisioning is having third-party applications that will actually do the work of communicating with the technology or the services, et cetera. So if you look at building a business, there's really four major functions, right? There's marketing, sales, operations, and finance. So for the marketing side, we're going to say, what are the best apps to build an e-store where you can advertise your products, your offerings, et cetera. On the sales side, how do you create something that does order processing, respond to RFQs and things like that that might come on the platform? The third component is what you just asked about, Eric, which is how do you get deep into things like, having consistency on that additive side, such as orientation, all the other stuff. And I'm not an additive expert by any means. I do know it's pretty complex. I do know that you have to think through how you do it. It's not just a question of, pressing a button. There are all these underlying questions. So we're saying, what's the best breed application that sits on top to control the additive side of the world? And we're talking to some companies that have software for that piece of it. And then on the third side, we'll have the payment exchange piece. So these four pieces, there might be multiple versions of this. And what we also want to be able to make available is on this platform, companies that have software that can do this should be able to plug in their software as a service on the platform. We don't want to make this a closed platform. If they can find someone, or if they are able to attract customers and they can put their software on this platform and make this part of the app store, we're hoping that's where those problems will be addressed, those challenges will be resolved, etc. So that's kind of how we're thinking about it. But again, as I said, we are building a foundation. But if the community has knowledge, and by the way, of all the participants that are out there, it's that bell curve of knowledge. Some of you are going to be experts that have done, decades worth in additive, and some of you might have just heard of the term, over the last 6 months. It doesn't matter, because that community participates in building that knowledge, and we are the convener of that community.
So one of the things, I had a conversation with Greg Mark, the CEO of Markforged. One of the things Markforged has is they have a laser that ships with every 3D printer. And what he tells me is that and I think it's out already, and Matt would know this. So they have the ability to, every time they lay down a layer of material, to have the laser take a laser measurement of that. And what you get is, at the end of that part creation, you get how much does the part deviate from the perfect CAD model. And when you print one off, you're stuck with that model. But what happens is, when you print at scale, you print 300 parts at a time, you can actually, among all the printers, you can create a bell curve that says, here's perfect in the middle, and I'm now going to throw out as scrap the 5% on either end of that perfection. So that's a way to print at scale, and you can tighten your perfection as much as you want. How much around that bell curve do I want to be along the center line? Because I can now do that, and I can actually build that in to my pricing. that says, look, you know, your printer, you could print the part and it could get thrown out. Hey, yours didn't make the cut. You're still going to get paid because everybody gets paid off delivery of the parts, but your part didn't make it because for whatever reason it deviated too far from the center line. Those are things we can do now in 3D printing, but you have to be able to do it at scale because you know you can't do a one-off. You do one, you're stuck with that. And then if you know if you have to print a second one, you have to charge twice as much. But when you do it at scale, you're able to factor in the scrap of the ones that are the outliers, and you're able to measure that.
This next one I think is for you, Pavan. Is the machine learning process part of the blockchain network? And is it based on proprietary software, or is it software that we need to purchase in-house?
So I think that this might be more for Matt. I think this
Okay.
was in this was reference. I'm assuming
Yeah.
referencing the
Yeah, I
slide
think.
that Matt had.
Yeah.
So, you
Yeah, I
go.
think. Yeah, and no, it is not, and it's running in the background. So no, there is no machine learning software that you need to purchase. It is basically the backbone of the cloud network that is monitoring / running the printers themselves. So in the background, the Markforged data science team is monitoring the prints, not what are you printing or how you're printing or what the product is, the position of the print in order to make its next generation that much better. And just to add kind of back onto Tom's point, those are the X7s that have the laser beds, not all the Mark IIs, but that product would still be relayed back to the MPF or the print file itself. So the new generation of print file, whether it's on an X7 or a Mark II, could potentially be the same.
Yeah, I will talk a little bit about the question of purchasing software. So one of the ways, and this is going to be the foundational philosophy of the economy moving forward.
This has to be the last answer too, because we got to get them off to the next session.
Oh, wow, yes. I'll be real quick. So the objective of this economy is that we get away from this world of software licensing as we know it, where we pay some upfront money depending upon and not know whether we're actually going to be using it or not. This is going to be much more of a service-based model. So anytime you use services on the network, you will pay for that per use for that service. And so it becomes a much more efficient model. Let's say someone has some really complex AI model for generative design. You use that, you use the computing cycles for that, you might have some cost that gets paid in this cryptocurrency, that gets embedded into your product cost, that gets embedded into your design. And now what you have is sort of this much more scalable business model for software, as opposed to spending thousands of dollars on software, which you may or may not know what you're going to use. So.
Well, I just want to thank everyone. Thank you, Matt. Thank you, Pavan. Thank you, Tom, for your time. Again, you know, there's still plenty of breakout sessions left, so be sure to join them and enjoy the rest of your day, guys.